So we're looking at some homework problems from worksheet 7, the applying log properties here. So we're going to use log properties to combine this into one log. So the first thing that sticks out is this base 16, base 4, base 4. So we need to change that to base 4. So we're going to just rewrite these ones. And we're going to apply the change of base formula here. So base 4, 2xy, and this is going to be base 4 of 16. Okay, so this log base 4 of 16 works out to be 2, so I'm just going to move it over a little bit here. So I get log base 4 of 4xy squared minus, and I might as well combine, maybe we'll just combine these as we go. So we're going to end up with 4xy squared in the numerator. Since positive logs in the numerator, the negative log goes in the denominator, so I end up with 16 x cubed y plus 2 log base 4 of 2xy over log base 4 of 16 is 2. So what ends up happening is those 2's cancel out. And so now I can combine this all together. I'm going to simplify in this next step here. So log base 4, this is going to be y on top. I've got x squareds on bottom and an extra factor of 4 on the bottom, plus log base 4 of 2xy. Okay, so then combine those two logs, we end up with log base 4 of 2xy squared over 4x squared. So log base 4, this becomes y squared over 2x. Okay, so there's this. Now we could possibly simplify that because that's base 4, base 2, and they're related, but we'll leave it as that. The other question for this is question number 3, looking at these embedded logs. And basically to deal with embedded logs, there's two ways to get rid of logs. Either use definition of logs, or if you have log equals log, you can drop the logs. In this case here, we do not have the option of dropping logs because we do not have a log equaling another log. So the only option we have here is definition of log. So I'm going to apply the base 2 on the outside. So we have to work outside in. So that base 2, that's my power, and that's going to equal the argument, which is itself a log. Okay, so once I've applied that, first I've gotten rid of the outside log. Now I can do the same process to get rid of this next outside log. So that is 2 to the power of negative 1 is 1/2. So then I'm going to use the base 16. That's my power 1/2. And that's going to equal log base 81 of x. Okay. All right, so there is the next step here. So I need to then do the actual square root. So I'm just going to do it down here. So square root of 16 is 4 and becomes log base 81 of x. I can now get rid of that last log by using again the definition of log. 81 base power 4 equals x. Okay, so there's my solution here. So this next one is exactly the same thing. We're just going to work outside in to get rid of the logs. We have no option other than using definition of log. So I'm going to convert this to exponential expression. 4 to the 1/2 equals the argument log base 3 log base a 512 x to the power 18. Okay, so 4 to the power 1/2 is 2, so that's my new base. 2 is my new power. And then I get log base a 512 x to the 18. So that is power, that becomes not 3 to the power is 2 is 9. That's my new power. a is the base, so I get a to the power 9 is equal to 512 x to the 18. I think the question asked to, or just asked to eliminate the logs. So that's the solution, eliminating the logs. But we could actually solve this. If I wanted to solve this for a or x, let's solve for x. So I'm going to divide, I'm going to have a to the power 9 divided by 512, and 512 actually happens to be 2 to the power 9. And this equals x to the power 18. So if I want to take the 18th root of this, I'm going to end up with a to the power 1/2. Okay, I'm going to use a power, the 18th root is a power 1/18, so 9 to the power 1/8, power 9 to the power 1/18 power becomes power 1/2, and then this becomes the same power, and I've solved for x. Okay, so I'll just simplify that. It's the square root of a over 2. So we could actually solve for x once we get rid of the logs in this case.